Hello guys, welcome to this video. This is Dr. Moorthy, Assistant Professor, Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics, and in this series we have discussed about different topics, and in this video we are going to discuss about a specific topic called centroid of different shapes and sections, right? So initially we should know what is centroid, right? The centroid is the geometry center line of any regular object. For an example, if you take a square, a rectangle or circle, the midpoint is the centroid point of a particular shape. So the geometric center of a 2D area or 1D line, the volumetric center of 3D object. If you, for example, if it is the 2D frame, the center point is the centroid, and if you take a three-dimensional object, it is considered as center of gravity. So it is the point where the entire area, length and volume can be considered to be concentrated. So this is to be a centroid for geometrical shape. And if you take a three-dimensional object, the center of gravity is where the entire weight of the particular object to be concentrated on the particular point. So that is center of gravity. So in this diagram, you see the centroid in geometry. The first, it is the triangle, then square and circle, and the centroid of plane area. So geometrical shape, composite area, and the moment of inertia, and the symmetry concept. The symmetry concept means the object or the particular shape is symmetric about x-axis or y-axis, and it is symmetric about both x and y axis, or else it is symmetric about none of the axis. So see here we have different shapes, and it is centroid. The first one is, it's a rectangle. So where the centroid we can consider as x bar and y bar. The midpoint of the particular rectangle is to be centroid. For example, if x centroid is x bar and then y centroid it is y bar. So x by or b by 2 is the x bar and d by 2 is y bar. Similarly for triangle, this triangle we should consider the particular concept called 1 by 3 and 2 by 3 concept. If it since it is a triangle, so if the triangle is considered from the base of the triangle, so in the it is 1 by 3 into height of height, and in the x bar it is b by 2. And for a semicircle, that is another concept for the semicircle and quadrant. 4r divided by 3 pi. If it is measured from the base of a semicircle or quadrant, it is 4r divided by 3 pi, and if it is measured from the opposite side, it is r minus 4r divided by 3 pi. So this is the formula for rectangle. Area is the b into d, x bar b by 2, for y bar it is d by 2. Similarly for semicircle it is x bar it is r, and then y bar is 4r divided by 3 pi, since it is measured from the base of semicircle. And for triangle, it is area of bh, y bar is 1 by 3 into h, x bar is b by 2. And for the semicircle, if the base is in the opposite direction, so the formula will be different. Then centroid for circle, it is considered as midpoint of circle. That is a d. If you take r radius, so x bar is radius, y bar is radius. And for quadrant, as I said earlier, it is 4r divided by 3 pi if it is measured from the base, and if it is measured from the opposite dimension, you can make it as r minus 4r divided by 3 pi. It is so this formula is depends on where the base is located, whether it is in the x-axis or in the y-axis. So based on that it will be different. So next one is we have a different method to find the centroid of particular shape called geometric method, method of symmetry, method of moment. It is also called as first moment of inertia, then composite shapes method, integration method, and graphical method. So each method have its own unique concept. And first, the center of gravity, as I said earlier, the center of gravity is the center point where the entire weight of the object to be concentrated, and it is more with the three-dimensional object if it the object having the volume, right? So the imaginary point in an object where its total weight is concentrated and acts. So the balance point of an object, and it is supported in the center of gravity, and the object should be in the equilibrium conditions. As the diagram says, we have the object in the stable equilibrium, and then another one is it is unstable equilibrium where the entire weight of the particular object to be concentrated on the single point. That point is called center of gravity. So this is an example for center of gravity, where in the left side diagram, either side the weight is equal, so that the object in the equilibrium state, and then another one is in the similarly have the body is in the center line, so either side, uh, if it is the particular point, the weight to be concentrated, and the third one the body not center line, it is a see the base of support is not in the fixed one, so that the center of gravity is the balance point between upper and lower body. If either of those variable changes, the center of gravity will be varying. So this is with concept with the center of gravity. Thank you.